Greetings aficionados, and in this video we are going to go through the solution to challenge number 6. So of the two letters we are given from the answer, R is the 18th letter of the alphabet and F is the 6th letter of the alphabet, but because we want to make it later than R in the alphabet, we'll add 26 to 6 and treat F as the 32nd letter of the alphabet, and that means that F comes 14 letters after R, and that makes our decoded spacing, which is our D space, 14. Now we can see that in the encoding process, R got encoded to O and F got encoded to Q, so let's look at those two letters O and Q. O is the 15th letter of the alphabet, Q is the 17th letter of the alphabet, and therefore they are two letters apart in the alphabet. So that's in our encoded message, or the encoded spacing, so the end space value here is 2. We need to work out end space divided by D space. 2 divided by 14 is not a whole number, so we add 26 to the end space value. 2 plus 26 gives you 28. Divide that by 14 and we get 2. This is the first time we get an even number from the end space divided by D space. But if we look at the multiplier partner table, we see that 2 is not a possible value of the multiplier. Looking at all of those possible multiplier values, they're all odd numbers, but so 2 is not possible. Now we see this is the first instance of something interesting that happens when end space is an even number and we have a multiplier on the right hand half of a table. So if we've got a value of n space that is an even number and a multiplier that turns out to be 15, 17, 19, 21, 23 or 25, then when we work out n space divided by d space, we get a value that is exactly half the alphabet apart from what the multiplier is. So we get a value that's exactly 13 out. So if we get an even number for the n space divided by d space, we need to add 13 to get the correct multiplier. So since we got 2 when we worked out n space divided by d space, adding 13, 2 plus 13 is 15, that will be our multiplier. Now we have worked out that the multiplier is 15, and if we use our multiplier partner table, the partner of 15 is 7. Let's work out what our Caesar shift was. So R is the 18th letter of the alphabet, and the multiplier used is 15. Work out 18 times 15, that is 270. Divide that by 26, we get a remainder of 10, and the 10th letter of the alphabet is J, but R actually is encoded to O, so we need to get from J to O, which means moving forward 5 letters in the alphabet. So that tells us that the Caesar shift is 5. We could have used F to work out that Caesar shift as well. F is the 6th letter of the alphabet. Multiplier uses 15, work out 6 times 15, giving us 90. Divide that by 26, we get a remainder of 12. 12th letter of the alphabet is L. But F actually encodes to Q, so since we're at L at the moment, need to go forward 5 letters to get to Q. So we are trying to encode the message or decode the message KBOQ BXS. So replacing each of those letters with its position in the alphabet gives us a first row of numbers. We have found that the Caesar shift is 5, so to undo that, we need to add 26 minus 5, so we need to add 21, and that's how we get that second row of numbers. The multiplier was found to be 15, so the partner of that is 7. So taking that second row of numbers, multiplying by 7, gives the third row of numbers. Then we need to take the remainder on division by 26, and if there are any zeros in that fourth row, which there are not, but if there were any zeros, they'd be changed to 26. And we need to replace all numbers with the corresponding letter in the alphabet. Happy affincionadoing, and see you in the next video for the next challenge.